we'll see. Good afternoon. Today we'll see about the supports, loads, and the problems based on supports and loads. Supports are used to provide suitable reactions to beams or any body. Which following steps are supports are used: simple support, roller support, hinged or pin support, fixed support. In the simple support, the reaction force acts perpendicular to the simple support. Whereas for the same roller support, the reaction force acts perpendicular to the roller support. The hinged support, the two reaction force will act. That is, one is a horizontal reaction force and another one is a vertical reaction force. Whereas for the fixed support, one reaction force is on the horizontal wise and another reaction force is on vertical, and also moment. Either it might be a clock or anti-clockwise. Based on our assumption, on the final answer, we can decide either it is of a clockwise or anti-clockwise. The beams are of simply supported beams, overhanging beam, cantilever beam, and continuous beam. These are the beams. The simply supported beams is nothing but the support acts at both the ends. Overhanging beam. The overhanging beam, after the supports are there, some length of beam will be extended. That is overhanging beam, cantilever beam. It is similar to the fixed support, and the beam will be hanged without any other support in the end. It's called overhanging beam. Continuous beam. Continuous beam supports are at equal distance. It is known as continuous beams. Loads. Loads are of three types: point load, uniformly distributed load, and uniformly varying load. Point load, a particular load of weight is act at any point of the beam or bar or any the structure given. Uniformly distributed load. The uniformly distributed load, a load will act, some amount of load will act for a particular distance. 2 kilonewton load is uniformly acting for a particular distance of 15 meters. Then we used to call it as uniformly distributed load. Uniformly varying load. Uniformly varying load, it will vary from 2, 4, 6, 8, and 10 kilonewton for a particular distance. All these loads are need to be converted into point load, and we have to solve the problem. Let's get into the problem. Here the figure shows that there are two beams, and it is a point load of 500 Newton acting at the beam CD. The support at A is simply supported, and the support at B is simply supported. At C, it is a simply supported one, and it is hinged support at the point D. We have to calculate the reaction force at point A and B. First, we have to draw the free body diagrams of both the beams for A and beam 1 and beam 2. For beam 1, the reaction forces are acting at point A, B, and C. All the reaction forces are vertically acting. The point A vertically downwards, and point C also vertically downwards, and point B vertically upwards. Whereas for beam 2, since we assumed the RC direction downward direction to maintain the system in equilibrium, we have to assume the RC force in the upward direction over here. The given weight is 500 newtons acting downward direction. The point D, since it is in the support, there will be two reaction force. One is of vertical, one is of horizontal. We have to consider the beam to solve the problem, since we are having few known data over there. To identify the horizontal force, the given system is of equilibrium conditions. Therefore, sigma Fx, sigma Fv, and sigma m. These are all equivalent to 0. So the horizontal force will be of 0 over here, since no other horizontal force acts here. The second equation is for vertical. RC in the upward direction and VB in the upward direction, and minus 500 in the downward direction, that is equal to 0. And by equating this equation, RC plus VD is equal to 500, let it be equation 1. Then we have to identify the moment for the beam 2, that is moment for D. MD is equal to RC into 600 and minus 500 into 400. Minus 500 into 400, it is, since it is in the clockwise direction, we have to take it is minus 500 into 400. We'll get the RC value as 333.33 Newton. Similarly, then the value of RC have to be substituted in the above equation. We have to identify the RA value. For the beam 1, we have to substitute the known values and we have to identify the RB value. RB value of 777.7 Newton. Thank you.